Hi, Rufin. How are you?
Good on you, sir.
Oh, I'm good, thanks, man. I'm good, thanks. How is the whole day going?
It's all right so far, sir.
Oh, that's nice. That's good to hear, man. Let me just quickly share my screen so that we can dive into nice business. Who just joined the lesson? Bongani. Hi, Bongani. How's it?
Yeah, I'm here. Fine, sir. How are you?
I'm good. I'm good, thanks. And welcome into mathematical lesson for grade 12 tonight.
Yes,
Uh,
sir.
can you guys see my screen that side?
Yes, I can see your screen.
Yes, sir.
Oh, all right. Thank you for the feedback, guys. I love hearing that. Let me then continue with tonight's business. So, in tonight's lesson, guys, we will be doing these two proofs here, theorem 1 and theorem 2. We know that theorem 1 was the one for proportionality theorem. This one was proportionality theorem. And then we'll also be looking at this proof for theorem 2 here. So let me just go to that theorem 1 without wasting some time. So we've got theorem 1 here that is stating that a line drawn parallel to one side of a triangle divides other two sides proportionally. So we are given this triangle here, A, B, and C. And then they are saying that this line is drawn, and this line that is drawn is parallel to one side of a triangle. That line divides this side and this side proportionally. That's a proportionality theorem. Then we knew that from this theorem, if we are given that in this triangle ABC, we are given that PQ is parallel to BC, we can come to the conclusion that AP over PB is equal to AQ over QC. So we now have to prove that this is true. How can we prove that? So in your exam, what you will be given, you will only be given something like this. Uh, you will only be given something like this. You'll be given your A, B, and C. And then you are given some parallel line here, PQ, here. And then it's parallel to that other side of a triangle. Then you are required to prove that AP over PB is equal to AQ over QC. And before I can continue, I just want to confirm if everyone can hear me.
Yes, sir.
All right,
Yes, sir.
thank you, guys. All right, thank you, guys. So, if this is what you will be given in the exam, in order for you to prove this equality here, what you first need to do is to construct these heights here. Let me go back to the original diagram that was drawn there. So as they did, they first constructed those perpendicular height in the upper triangle, in this triangle, in this upper triangle. You first construct those perpendicular height. The other height will be perpendicular to AP, and then you construct the other one that will be perpendicular to AQ. Okay. After you are done with that, you name them. The other one will be H1, the other one will be H2 for the height one, and then for the height two. Then you come to this other part that is below on that triangle. You also join these letters BQ here. You join them with some lines. Then you join also these ones. Okay. Then you are done just like that. And then now we can write now. You start with your proof that construction in that triangle that we said we first construct, which is this one. You write it in triangle APQ, which is this part. Draw H1. This one doesn't matter. I mean, whether H1 is this one or this one, whether H2 is this one or this one. What you need to be specific with is that if in your diagram, this is your H1 and your H1 is perpendicular to AP, you must indicate that draw H1 with a perpendicular base AP and H2 with a perpendicular base AQ. And then afterwards, you continue with your statement with this construction that you have made in this other part, that now draw this line BQ and this other one PC. Then you are done. That's a mark. Does it make sense up to so far, guys?
Yes, sir.
Yes, sir.
Okay. I got feedback from 2 people. What about others? Are you all guys okay?
Yes, sir.
All right. All right. Thank you, guys. Now we come to this part. If you're sure that you understood this one. Okay. Now we go back to that area part, keeping in mind that if you have got the triangle A, B, C with some height H here and the base, remembering that if you are required to find the area of that red triangle there, the formula will simply be this half times base times height. Okay, we know this formula. Then let's continue with our work. Now we are here, what we are going to use now, we are going to first focus on this side as the basis of the triangles that we are going to use. Okay, the numerator, we take this triangle APQ as they did. Okay, and then what's the formula for the area of triangle APQ? We know that the formula for the area of a triangle is equal to half times base times height. And then now what is the base for this triangle? Like I said that we are first going to focus on this side. So the base for this triangle will be AP. So we take half here, they did, and then with the base AP, they did, okay, and then they took the perpendicular height, which is this one, H1 here. Okay, they did. Now all over the below triangle, which is this one here. Okay, triangle BPQ. And then that BPQ still have got the same height, that one, because it's the one that is perpendicular to the base. Okay, so it's going to be half times the base of that triangle, which is now this one, PB, times the height, perpendicular height, H1. Okay, after you substituted that, now we are in this part whereby the H is the same, it cancel each other, the halves cancel each other, then you are left with AP over PB. Does it make sense up to so far, guys?
Yes, sir.
Yes, sir.
Okay. Okay. Now, after you are done with this side, guys, okay, you're going to that side, you do the same thing. But okay, now I'm on this triangle, but now I'm going to use that side. Okay, then now what is the formula for the area of the triangle? This is the formula for the area of the triangle. Is A is equal to half times base times height. So we already have our half there. Okay. And then the base for this triangle, we said, okay, we're going to focus on that other side. So the base for that triangle is going to be AQ. What am I now doing? This is the base for this triangle AQ times the perpendicular height, which is this one. Perpendicular height is going to be H2. Okay. Now we go to the other part of the triangle. So, I mean, for the area for the denominator, which is the area of the triangle CQP, which is now this one. Okay, they've got the same perpendicular height as the first one because it's perpendicular to the base there. Okay, and then the base is going to be QC here times the height, the perpendicular one, which is H2. Okay, you are done with substitutions. Now what you're going to do, the H2 cancel out, the halves cancel out, you are left with AQ over QC. Therefore, now the area of triangle APQ over the area of triangle BPQ is AP over PB, okay? And the area of triangle APQ all over the area of triangle CQP gives us AQ over QC. Then you are done with the half of the proof. Does this part make sense to everyone, guys?
Yes, sir, I understand.
Okay, he does understand. What about others? Does it make sense to you guys?
Yes, sir.
Okay, I got feedback from 2 people, I guess. What about others? I just want to confirm, guys, don't be annoyed. I just want to ensure that everyone is comfortable with this proof before I can proceed to other parts. Are you guys okay up
Yes,
to
sir.
this part? Okay. I think I got enough feedback. So let's continue with the last half of this proof. Now, we come to this triangle. That triangle BPQ and triangle CQP. Which triangles are those? Triangle BPQ. BPQ is this triangle and triangle CPQ. CPQ is this triangle. Okay. Those triangles have got the same base that I'm going to highlight with the blue color there. That's the base for the two triangles. And those triangles lies between parallel lines, those that are green there. And then those triangles that are between parallel lines and they've got the same base, they have got the same area. Do you guys still remember that property when we were still doing something there on proportionality theorem when we were calculating some areas?
Yes, sir.
That triangles with the same base that are between parallel lines have got the same area. Do you all guys still remember that property?
So, please just write it down.
Sorry?
So, please just write it down. I remember about it, just to remember how it looks. Like the
Oh,
rule
okay,
itself.
okay,
That's why
okay.
you
It's
just
fine.
write it down.
All right, not a problem. Let me just write it, excuse me, here. If these are our parallel, this is the first line, maybe. Okay, just a line. And then this is the other line, such that this line is parallel to this line. And then I've got this triangle here. This one, okay, let me use maybe different color. Say maybe red. Say this is the triangle Okay, this triangle of mine is A, B, C. And then now the maybe let's say the distance between these two parallel lines, let's say is K. This distance between parallel lines, okay, is perpendicular there. And then now this part here from B to C, let's say it's B. And then now I'm asking you guys, what is going to be the area of this triangle here?
Does it not have base times height?
Sorry?
Half of the base times height.
So, okay, it's half of the base times height. Yes, 100% correct, sir. Thanks for the answer. And then now, the base of this triangle, we are given that part is B times the height is this part, the distance between parallel lines, which is K in this case. Okay, then I believe you all understand this. If there is someone who doesn't understand, you guys will just shout out what you don't understand. So let me go for the other color to draw another triangle. Say maybe, okay, it's this one here. This one here. This triangle is going to be DBC. The blue one here, DBC. Okay, we said the area for the red triangle is going to be half times base B there. We can see it's B, okay, times height, which is K. That's it for the red triangle. Then the area for the blue triangle is still the base times height times half. So it's going to be half times the base for this blue triangle is still BC, which is B times the height. So because this triangle is still between those parallel lines, it will take this height K. Now we have shown diagrammatically that the area of the triangles with the same base, in this case is BC, between parallel lines have got the same area. Does it make sense now to everyone, guys?
Yes, it does.
Yes, sir.
Okay. Okay, thank you, guys. So this is what that line is saying there. Now it only took these triangles here, this one and this one. That's what they were saying, that triangle BPQ and the triangle CQP have got the same base PQ, which is this line here. And these triangles are between these parallel lines PQ and BC. Therefore, now we can come to the conclusion that the area of these triangles, which is now this part, the area of those triangles are equal. Reason being, same base, same height. Okay, that's all. And then now we can come to this part. Now the area of triangle APQ, actually, you just take what you had, that area of triangle APQ all over the area of triangle BPQ. Okay, you take that, you equate that to this part here. That is equal to the area of APQ all over the area of CQP. And then now, okay, we said the area of BPQ is equal to the area of CPQ, meaning this part is equal to this part, okay? And that part is the same thing. Therefore, for this part, we had AP over PB, which is this one here. And then for this one, is this one. Therefore, now you can just equate that. We are now convinced that if you are given that this line is parallel to this one in this triangle, you can come to the conclusion that AP over PB is equal to AQ over QC. Just like that, you are done with the proof for the proportionality theorem. Is there anyone with some questions, guys, before we can proceed to other parts of the session? Is there any question that you guys are having? If you are curious with something.
No, sir.
Okay. You don't have any question? What about others? Are you guys okay?
Yes, sir.
Yes.
All right. All right.
Yes.
Thank you, guys. Then now, thank you guys for the feedback. Let's proceed to this theorem here. Oh, okay. Theorem 2, the similarity one, that you are saying if two triangles are equiangular, and now we know what does equiangular term mean. Okay, if those two triangles are equiangular, then their corresponding sides are in the same proportions, and hence those triangles are similar. Okay, we can see that these triangles are equiangular because this angle is equal to that, this is equal to that, this is equal to that. Okay. Now, if those triangles are equiangular, then the corresponding sides of these triangles are in the same proportions. So these are those proportions that they talk about, and hence those triangles are similar. Now we want to prove that if we are given that these triangles are equiangular, then we want to be sure that this is true, that the size of these triangles are in the same proportions, and these two triangles that are similar. Okay, now what you are going to be given with this question in the paper, so you will just be given the bigger triangle A, B, C, and the smaller triangle D, E, F, and then be given that these triangles are equiangular. Say maybe this is that dot, this is that dot, this is that star, this is that star, this is that O, this is that O. This is only what you will be given in your exam if you are being assessed on this proof. You will be given this bigger triangle. It's empty. It doesn't have this constructed line here. Okay, you are the one who's going to construct that. You will also be given this smaller triangle. So now the first thing that you are going to do on that empty bigger triangle, you will mark off the letter P. You write it that P. Okay, they already wrote it here. Okay, on the side AB, on this side. Okay, and then you mark Q on the side AC. You write that Q, and then on that side AC, on this side AC, such that AP, only this part, will be equal to DE, and this other part AQ will be equal to that part DF. And then now you join your line PQ. You join your line PQ. You also write this on the answer sheet that, okay, I marked the letter P on the line AP and on the line AB, I mean, and then I also marked the letter Q on the line AC, such that my AP there is equal to ED, and my AQ there is equal to DF, and then I just joined PQ. Okay, does it make sense up to so far, guys?
Yes, sir.
Yes, sir.
Oh, all right, thank you, guys. Now we are just going to prove the congruency, not the similarity. Now, for now, yes, the aim of the main question is to prove the similarity. But for now, we are just going to prove the congruency between these triangles. On the first bigger triangle, you only take that upper triangle, and the other smaller triangle, you prove the congruency between those two triangles. Okay, what are we going to do? You know that this angle is equal to that angle. Angle A is equal to angle D. We are given that. That's our reason. Okay, and then AP is equal to ED by construction. That's the reason. We said that we marked that letter P such on the line AB such that AP is equal to DE. So yes, you are now allowed to say AP here is equal to DE by construction. Same applies on the other side. You're going to say AQ is equal to DF by construction. It's your reasoning. Now we used those three conditions. We have proved that this triangle and this triangle are congruent. We used one reason and two sides. Therefore, our reasoning is going to be side, angle, side. Okay, we are done with that. Now we go back to this congruent triangle. Now we can say this angle P1 here is equal to that angle E. Reason being the what am I doing? Reason being the congruent triangles in this triangle and this triangle. Okay, we are done with that part. Now what we are going to do, because we know, let me just do this. We know that P1 is equal to angle E, congruent triangles, and then we were given that this angle B is equal to angle E. This was given. Now you can come to this conclusion that these angles are equal, reason being they are both equal to this angle E here. That's your reasoning. They are both equal to that angle E. Then if now you are sure and convinced that these angles are equal, you can come to the conclusion that this line and this line are parallel, reason being the converse of corresponding angles. And then you state your equal angles now that angle P1 is equal to angle B. Okay. If you are done proving that parallelity there, now you can see that now proportionality theorem applies because, okay, this is our triangle. Now there exists some parallel line that is parallel to one side of a triangle. Now proportionality theorem applies. That is why here they said, okay, AB, this part here, they said the whole side AB all over AP is equal to AC all over AQ. Okay, the reason being the line parallel to one side of a triangle, or you can say prop theorem, and then you state your parallel lines that PQ is parallel to BC. Okay, Now from that part, you can just substitute that AP, because AP, this AP here, you substitute it with DE because they are equal from this congruent part. And then also substitute that AQ there with this DF, AQ with this DF from the congruency. Then now you have proved that AB over AC, AB over DE is equal to AC over DF. Just like that, you are done proving that proportionality of the sides of these triangles. Same applies now. You're going to play around your sides of the triangles to prove the whole equality. And then now you can come to the conclusion that these triangles are similar. And then you are done with everything just like that. So is there anyone of you guys with some question?
No, sir.
Or, okay, are you all cool? I only heard a feedback from one person. Are you all guys okay?
Yes, sir.
Oh, okay. Okay, guys, I think we still have got more than 20 minutes. So I just want us now to go back to that grade 11 Euclidean geometry, just to remind ourselves, because we have been on this grade 12 part for some while. Excuse me, where are my files? These are my files. And then I'm just going to go. Okay. Then I'm having something like boom, boom. I want this one. So I've got this plenty of questions here. I want us to remind ourselves with this grade 11 Euclidean geometry. So I'm going to ask you some questions, guys. I want to go through these questions with you. The first thing that I will do as usual is DRCPT technique, Dr. Cape Town, just to do some analysis. Okay, let's first go to the statement. They are saying in the diagram, TP is the tangent, okay, of the circle at the point P. Okay, this circle for the center M. Okay, QS is the diameter to the circle. That means something. Okay, this is 90 degrees. Okay, and then R is on the circumference. Here we can see. Okay, and then TPS is equal to 32 degrees. That's what we are given. Excuse me, therefore DRCPT. For D, we already did that analysis, that this is the 90 degrees. So is there anyone of you guys who can tell us the reason behind that statement that this angle is 90 degrees here?
Angle in a semicircle.
Oh, yes, 100% correct, sir. I agree. That's correct. Angles in a semicircle. We are done with the diameter part. We go for R, the radius. Okay. Is there any radius, guys, in this diagram here?
Yes, sir.
Which one is it?
MS and MQ.
MS is a radius and MQ is a radius, yes. And then
And
this
MP.
line is equal to that line and MP, yes, sir, and these lines are equal. Therefore, now we can see that this triangle is an isosceles triangle because of this radii. Therefore, this angle will be equal to that angle, reason being the base of an isosceles triangle or the angles opposite equal sides. Also, when we come to this triangle here with this equal radii, this angle is equal to that angle, reason being the base of an isosceles triangle or the angles opposite equal sides. Okay, we are done with the radius. We go to C. Is there a cyclic quad, guys, in this diagram? Did you guys hear a question?
Sir, may you please repeat?
Oh, I was asking if there exists a cyclic quad on the diagram. Is there any cyclic
No,
quad?
sir.
Or are you
No, sir.
sure?
No,
Sorry?
Sir, there is no cyclic quad.
Are you sure?
no, yes.
Is that a yes, there is a cyclic quad, or yes, I'm sure that there is no a cyclic quad?
There is not.
There is not.
There is not.
I'm saying there is.
So if we were to construct RT, like join them, wouldn't it make PTQR exactly quad?
If you join this one.
Yes.
Conditionally, it would. On this condition.
Okay, sir.
So, does it make sense?
Yes, sir. Thank you.
Yeah, it was going to be a cyclic quad if we say we also construct the circle PQTR, then it will be a cyclic quad to this constructed circle.
Yes, I understand.
Yes. So, do you guys still remember the definition of the cyclic quad? Okay, let me ask you this question here. Okay. A, B, C here is a corner. This one, A, B, C, D, E. Is this A, B, C, D, E a cyclic quad here? The red one that I've just drawn.
Not exactly a quad, sir. Because it has more than
Why?
4 sides.
Why? Sorry?
It wouldn't be exactly a quad because there's more than 4 sides. It could be a cyclic pentagon.
Okay. Yes, quad. Oh man, I love that reasoning. I love that reasoning. It's an accurate one. So now let's come to this one. Let's come to this one. A, B, C, D. Is this a cyclic quad?
Yes, sir. It touches all 4 sides. I mean, it touches the circumference on all points.
All right, all right, all right. I agree. Now I come to you again with this question here. Okay, with my 4 edges. I've got A, B, C, and D. And then I ask you, is this a cyclic quad?
No, sir.
Why not?
If you have to connect AB and then if you have to construct AB and then construct DC, then it will be a cyclic quad.
Okay, what's the definition for a cyclic quad again?
A quad that touches where all 4 points touch the circumference.
Yes. At this point, are these not 4 points on the circumference?
They are, but they don't. But the shape itself is not a quad.
Okay. Now, okay, let me do this. Okay. Do you see those A, B, C, D? You agree that this is a cyclic quad?
Yes.
And you say this is not a cyclic quad?
Yes, sir.
Oh, okay. If maybe I was in front of you, okay, or maybe if you have got something like maybe a cloth with 4 corners or the paper in front of you, that is like this. Yes, the paper is like this. Okay, let's say that paper is a cyclic quad. You take that paper, you take this corner, you fold it towards the side, and then you fold this corner to that side until it forms something like of this shape. That is still a paper, right?
Yes, sir.
Yes, that is still a paper, but of just a different shape. From this shape, I just take this corner. I leave these corners this side. I'm only going to flip these corners this side up until I have something of this shape. Then it's still a paper. That is why I'm now convinced that even this shape of a bow tie shape is still a cyclic quad. I'm not sure if it makes sense to you guys.
Um,
Yes.
so what you're saying means that it doesn't go by the shape as long as the 4 sides are touching the circle. Since the definition says the 4 sides touching the circumference.
Yes, as long as those 4 corners of that part, that quadrilateral, touches the circumference, that is a cyclic quad.
Okay.
Are you now answered?
Yes.
All right. So yes, guys, if you see this theorem of angles in the same angles in the same segment or angles subtended by the same chord, angles subtended by the same arc, it's still the family of the cyclic quad. Therefore, yes, there exists a cyclic quad in this diagram, which is this one. Therefore, you can say this angle is equal to that angle, angles in the same segment. This angle is equal to that angle, angles in the same segment. Okay, we are done with that part for C. Let's go for T, which is the tangent. Obvious, there is a tangent to this diagram. So I'm going to ask you guys this question. Do you guys agree when I say this angle here is equal to that angle there?
Hmm.
So may you please repeat your
Hmm.
question?
Oh, I'm asking if you guys agree when I say this angle here is equal to that angle there?
Yes, I agree.
What's the reason behind that statement?
These are not 10 chords, sir.
Are you
Angles in the
asking?
same segment.
Are you asking or telling me? Or that I want
Yes,
that one of the reason turn chord.
yes, 10 chord. I think for
Now you are
Q1
telling.
equals
Now you are
to,
answering, right?
yes, sir.
Oh yes, 100% correct. This is turn chord theorem. I'm also correcting that one who said angles in the same segment, because remember, we are now talking about this angle that is between the tangent and the chord. In the triangle that is in the circle, it will be equal to the angle that is opposite that chord of focus, reason being tan
No,
chord
sir.
theorem.
I
Sorry?
I thought you were still talking about the previous one. That's why I said that.
Okay. It's fine. Okay, thank you. I'm sorry for just assuming that you were answering to my question. And then also you can go to that other side, that this one is equal to this one, reason being tan chord theorem. Okay, we also have that theorem that is stating that this is not a tangent. This is a tangent, this is a radius. There is that theorem that is saying radius is perpendicular to the tangent. Therefore, this angle here is 90 degrees, reason being rad is perpendicular to tan. This angle is 90 degrees, reason being rad is perpendicular to tan. Therefore, we are now done with the analysis of DRCPT. We can now dive into the problem and see if we can cook something. 2, 4, 6, that's 4, 10 minutes, 10 marks. Okay, they love saying that. Now calculate the following, giving some reasons. The angle Q1, this is Q1 right here. Is there any one of you guys who can tell us what the size of angle Q1 is? Are you guys still there with me in the room?
Yes, sir.
Yes?
Yes.
You want to talk?
Sir, may
Is
please
there
repeat your
anyone?
question.
Oh, okay, my question. I was asking if is there any one of you guys who can answer question 9.3.1, the one that is requiring us to find the size of angle Q1 with some reason?
So can you please zoom in a bit?
Oh, okay. Let me do so. Is it now okay?
Yes, sir. Thank you.
Oh, okay.
So
Yes, sir.
we can say that Q1 is equal to angle 32, and then say that the reason
I
is
am
10 given.
100% correct, sir. I agree. Angle Q1 is equal to 32 degrees, reason being tan chord theorem. I agree. Thank you, sir, for that. We are done with the first one. Then the second one, 9.3.2, is requiring us to calculate the size of angle P4. P4 is this one here. And then, is there any one of you guys who can share some idea of that question? It's not that bad. I believe in you guys.
P4 equals to 32.
Okay, P4 is equal to 32. I agree. What's the reason now behind the statement?
It's angles opposite equal sides.
Angles
equals to
opposite
Q1.
equals 5. I agree 100% correct, sir. Then now we can proceed to the next one. 9.3.3. We are now required to find the size of angle M1 with some reason. Is there anyone who can give this one a try? M1 is just this one here.
So M1 is 64 degrees.
M1 is 64 degrees. I agree. What's the reason behind that statement?
Angles on a straight line.
Angle on the straight line. So you first calculated this one and then you came to this one.
Yes, sir.
Oh, okay. That's a good approach. And then I can also see this one here. You guys, I think you do remember this property here, that if I've got this angle as A, I've got that one as B. This angle will be A plus B. Reason being exterior angle is equal to interior, is the sum of interior opposite angle. Do you guys know that property? So it was going to be this 32 plus that 32, then it gives me 64. Do you guys still remember this property?
Yes.
Oh, okay. Yes.
Yes, sir.
Yes.
Sir,
Yes, ma'am. Was that someone who was calling me? Or what's happening? Is there anyone who said yes, who said sir?
I'm supposed to be a little question.
Sorry?
Oh, Sam, I wanted to ask that she said M1 is equals to P3. Isn't it another reason that it says angle at what's that is 2 times the angle at the circumference?
That's also the good approach that you can use. Yes. You
It
still
can
can say
apply.
yes, this is the angle at the center is 2 times the angle at the circumference.
Okay.
Are you now okay?
Yes.
Are you sure?
Yes.
It seems like you are doubting that you are somehow not sure, but then if you are saying you are sure that you're okay, it's fine. Let's proceed to the last one, 9.3.4. We are now required to find the size of angle R with some reason. Then this is, what am I doing? This is what we are required to find here. This one. Anyone, guys, who can give this last one a try?
58. So the answer is 58.
Sorry?
The answer is
You are
58.
saying 58.
Yes, sir.
How did you do it? Mind sharing some approaches that you use?
So we can use an approach of angle at circumference is twice the angle at the same. Angle at center is twice the angle at circumference.
So, okay, you used this diagram, right?
Yes, sir.
And then this was the angle at the center, and we had it. And then you divide that
Yes,
by
sir.
2, and then you find this.
Yes, sir.
Oh, I 100% agree to that. It's all right. Is there any one of you guys who have got some question and curious about something so that we can clarify it before I'm logging out of the session. Is there any question that you are having, guys?
No, sir.
No, sir.
All right then, guys. Thank you for being with me in tonight's lesson. I appreciate it a lot. We will meet now in the next session. We are now done with Euclidean geometry. What we will do in next time's session, we will just do some revision on this grade 11 part, and then we will be done with Euclidean geometry. Or is there any part that you guys still need some help, even if it's grade 12's part, so that we can just include it in the next lesson? Is there any part that you guys are still finding some challenges, so that I include it on the next session? Oh, I believe you guys are okay with everything since you're quiet. Guys, I'm now logging out. Thank you for being with me. Just have a good night and a good weekend.